Okay, so functions. This is the new unit. This is a funny way of writing y. You can just write y equals, okay? And y equals x minus 5 is just fine. There's nothing wrong with that. It's just that when you write it this way, there's a couple advantages. Like if I write y equals x minus 5 and y equals 2x plus 7, they have the same name. They're both called y, and that's a little weird. You know, if I have two separate equations. See, when you have this way of writing functions, you can write one of them's f of x, and you can write a different one as like g of x. And see how they get a different name when they're different? My point is there are some advantages to using this f of x and g of x system. Here's another advantage. If I wanted to put a number into this function, like let's say I wanted to put in 7, I could put it there, and then the answer would be 2. But if it just says y equals, then you don't know what you put in. Whereas when it's in function notation, you say f of 2, and it's like you're saying, I put in x is 2. See, that's the advantage of writing f of x, is you can tell what you stuck in it. If you want to say, I stuck in 2, in this case, I stuck in 7. Let's stick in 2. So let's say I stick in 2. Then I get 2 minus 5 is negative 3. If all I had was the answer, it didn't tell me what I stuck in. See, if I just had y equals negative 3, then it doesn't tell me what I stuck in. Whereas f of 2 tells me what I stuck in. Okay. Next thing is input and output, and I got something really simple for you. X is the input. Just try to remember, we always start with x, and that's what you put in the function. Headphone, take that out, thank you. X is the input, and y is the output. But what did I say 2 seconds ago that we would sometimes use for y? F of x. All right. So keep in mind, when I say input, I'm talking x. Output, I'm talking y. All right. So I just want to look at a graph for just a second. Imagine you're at the football game, and time since the game ended. So like 1 minute after the game ended, some people have left. It's less than it was, right? A whole bunch of minutes later, all the people are gone. It's like 0 people. Here, let's say that there's like, I don't know, in a Minnetonka Stadium, maybe like 2,000. I'm just guessing. A couple thousand people at the stadium. Maybe it's more like 1,000. I don't know. I was at that game the other night with Edina. You seemed pretty packed, at least on our side. Felt like there was 1,000 people there. Anyways, do you think in the real world people leave exactly like this? No. Might it be more like a bunch of people leave and then it slows down, and at the end of it, like even an hour later, I bet there's still a couple people in the stands. I don't know why, but they might still be there. All right. So, or maybe it's a really good game and people don't leave right away because they're so excited, you know, like it was a really good ending and they're like stay around and kind of chat for a while, and then all of a sudden everybody leaves like really fast. Maybe it's more like that. Okay. So I just wanted to talk about how math in the real world, it isn't usually a straight line. Okay. If you put in an input, let's say this is like a pop machine and you put in $1. Man, it used to be $1 was expensive per pop. Now it's super cheap. You can get a pop for $1. All right. Remember, if I were to see a cell phone at this time, I have to write an email. You have to talk to your parents about it. It's no fun. Please don't do that. I saw somebody pick something up. I hope it wasn't a cell phone. All right. So the buck goes in to the pop machine, and you get a pop. And the next person puts in a buck, and it says, no, you need to put in more money. That would be like inconsistent, right? That doesn't make sense. You would expect that it would do the same thing every time. Or let's even make it like press. Nowadays, there's typically like, E5 or something like that on the screen, and then the pop comes out. Well, let's say you put in a buck and you press your E5 and you get your pop out. And then you go do it again, and this time it's a different kind of pop. You're like, what? I hit E5 again. I know I did. See, functions need to be consistent. All right. And this is just, you pronounce this f of x. Okay, we already did that. So I already used the vending machine example. So let's move on to this. Inputs, outputs. When you put in a 10, you got a 15. When you put in a 20, you got a 45. When you put in a 30, you got a 25. This looks weird, but the question really becomes, is this a function or not? And this is the hardest kind. So pay attention. I'll tell you how to tell if something is a function or not. What you look for is, was it inconsistent? It's like somebody pressed the button 1, 0, and they got a 15 out. Somebody else pressed the buttons on the pop machine that say 20, and they got a 45 out. Now, that's okay. It's different. This one is an example of a function. Even though it jumped around, when I put in 30, I got a 25. You know what would make it not a function is if I put in 30 again, and last time I got a 25, and this time I get a 20. That would make it inconsistent. Do you get what I'm saying? You type the same numbers, and I get something different. That is inconsistent, and that is not a function. All right, so I'm going to give you an example of that. 2 gives me 5. 3 gives me 7. 4 gives me 9. And 4 gives me 10. Is that a function or not? Nope. Because I put in a 4, I'm supposed to get a 9. I already established that. I put in another 4, I better get 9 or something's wrong. So that's not a function. Now this one's going to bother you, I think. If I put in a 5 and I get a 7, it's going to bother some of you. But it's still a function. Even though putting in a 3, like I type a 3 on the pop machine and it gives me a 7, do you get it's possible that I could type a 5 on the pop machine and also get a same kind of Coke? Yeah, they can do that. They can set that up. Welcome. All right, so watch out for this one because it happens to people all the time. And they're like, oh no, something's wrong. Nope, nothing's wrong. You typed in a 2 in the pop machine and it gave you a, I don't know, what do we call that? A Diet Coke. You put in a 3 in the pop machine, you also get a Diet Coke. That's okay. What would be wrong is if I put in another 2 and this time I get something completely different. I type 2 on the pop machine, little keyboard, and all of a sudden I'm getting like, wait a minute, I thought when you type 2 you're supposed to get a Diet Coke and I'm getting a Pepsi. Different. Input's the same, different output. That is not a function then. All right. And here's the last part, and I think I'm going to have a few more slides, but this is essentially it. If I have this graph here, do you remember back to algebra and they had something called the vertical line test? I know you may not know what it is, but do you remember those words? Vertical line test? It was a thing. Here's how it works. If you draw a vertical line, now you got to be a little smarter. You're smarter than you were the first time you took algebra. You're probably 2 years older when you took algebra. Let's say I put in an 8. This is the x and those are the inputs. And then this is the y-axis. Do you get that if I put in an 8, right now my function is giving me that, which to me looks like it's maybe 4. I put in an 8, I got a 4. Is there anything wrong with that? No. And I only got one output. That's a function. It passed the vertical line test. Then let me show you something that's not a function. It's neato, and there are math graphs that look like this, but they aren't functions. Because if you put in input, let's say right there, let's say that's where 8 is on this graph for the input. There's 3 different outputs. Do you get it hits here, and there, and there? It did not pass the vertical line test because when you typed 8 on the little screen on the pop machine, it gave you 3 different kinds of pop. 3 outputs. This is not a function. That is no f of x. This one was an f of x. This one's a function. All right, so I'll just give you a few more. A triangle, function or not?
No.
Nope. If I put in an input of, let's say, 6, I get two different outputs. This is like 6 comma 2, and this is like 6 comma 5. Like there's two different spots that come out. So that passed the vertical line test? No, that failed the vertical line test. This is not a function. F of n, f of x is a lot of different letters you could put in here. Usually we use f of x, but okay. I think you've got it. Time will tell. Is the pink one a function? I would think of this as, in our system here in the United States, you're innocent until you're proven guilty. I like that way of doing it. Where if somebody wants to convict you of something, they have to prove you did it. In other countries, it's actually the opposite. Like for instance, in Japan, if they say you did it, you have to prove you didn't do it. Otherwise, you're going to be convicted. And it may seem like the same thing, it's not. The burden of proving something is hard to prove. We have, in our country, we have to prove you did it in order for you to get convicted. So what am I saying? On this one, everything starts as a function. It's just, can you find any evidence that it's not a function? So far it's a function because, well, it starts as a function. But was there ever a time when it was inconsistent? Was there ever a time when it was inconsistent? No, there wasn't. There wasn't a single time. Now, if I had put in, oh, wait a minute, my glasses. I didn't have my glasses on. Hi, some of you looked at me funny when I said that. You're right. That was inconsistent, wasn't it? Sorry, I took my, I used to have perfect vision. In fact, I had better than perfect vision. It wasn't 2020, it was 2015. And then, all of a sudden, I got old enough. It sucks, but it's reality. When you're probably 45 or 50, all of a sudden, it's like, crap, I can't see anymore. Okay, so I had my glasses tilted up. That is inconsistent, so that's not a function. Until that moment, though, until it repeated one, I couldn't tell. All right, question or comment? Yes?
Yeah. What makes something inconsistent?
I put in a 2 I pressed 2 on the pop machine, and this time I got a Diet Coke. I pressed 2 on the pop machine again, and I got something different.
Oh, yeah.
If I press 2 on the pop machine, I should get the same thing every time. Yes?
I was gonna ask if that X was decided that you can't have like more than one number, right? You can't repeat the number like that.
Well, you can repeat a number, but it's got to come out the same. Like if I put in a 2 in the machine twice, that's okay. That's like I put it in my buck, I pressed 2, I got a 9. I just have to get a 9 again. Like that would be okay. You know what I mean? It was consistent. I pressed 2, I got the same kind of pop. It would be annoying if you pressed the same number but get different pop. You'd be like, what? I was trying to get 2 of my favorite kind of pop. So that, if I change that to a 9, now all of a sudden this thing's a function. All right, look at this one. Function or not? Well, at the beginning, they're innocent until proven guilty. That's a function. It can be anything until it repeats a number. Has this repeated any numbers? It never repeated a number over here, so it's innocent. I can't prove that it's not a function. All the inputs are different. So you can have 2 things in the pop machine that give you Diet Coke. That's okay. But if I had included another 4 here, see like this, and this time I get a 3, that would be inconsistent. Nope, not a function. If I add that 1 point, it wouldn't be a function. Now let me just show you kind of why this works. If I graphed all of these points, -3, -3 is like down here. -2, -3 is down here. 0, 4 is there. 4, 2 is there. 6, 0 is there. 7, 6 is there. 9, 10 is like there. Do you get it would actually pass the vertical line test? Think about it. I could graph a vertical line anywhere on here and it would never hit 2 points. Get what I'm saying? And if I would have added like another 9 and this time not a 10, maybe it was an 11, then it would fail the vertical line test, see? Because it would hit 2 points when you put in the vertical line. See what I mean? So all you're really doing is testing the vertical line test again. All right, this. But these aren't on a graph. How can I tell if it's, well, there's two different ways you could do it. You could graph them all, or you could just look for inconsistencies. I put in a 0, I get -5, it's innocent until I prove that it's guilty. Oh, I am going to prove it's guilty because look, I put in a 0, I got something different. It's not consistent, not a function. I put in a 1, I got a -6. I don't even care what I get at the beginning, it's innocent. I put in a 2, that's a different number. I can get the same thing or something different. I don't care. I type a 6 into the pop machine and I get something different and I don't care. And this 3, is that a repeat of any of these? Nope. And so it's innocent. I can't prove that it's guilty. It's innocent. It's a function. Okay. This should be super simple. Function or not? Nope. If you would do the vertical line test, look, if I put an input of 3, because C3 would be right here, it gives me 3 different outputs. That's not consistent. Fails the vertical line test, not a function. All right, congratulations. We've made it to the last slide. Function or not? Nope, wouldn't pass a vertical line test. Function or not is a function because anywhere you draw the vertical line, it only touches once. And this one, function or not? Nope. If I put an input of 10, I get 2 different outputs. Not a function. All right, now you have 6 little easy problems, and you've waited long enough that now, during the work time, you can use your cell phone without any fear of me having to write you up. Okay, so use this time well. During this time, I'm going to hand back those tests. And during this time, I want you to understand that if you fell down on this first one, that doesn't mean you're doomed in this class. Like, if you trip in the middle of like a boxing match and you fall down, it may be embarrassing. Get back up again and keep going, okay? So if you had a rough first test, nobody knows yet because I didn't type them in. But I'm going to hand them back to you. If it went well, awesome. There's a lot of people that just got like a B and they were like, I thought I knew this stuff like to an A. I want you to understand how I do retakes. All right. Let's say you've got a B and you want to retake for an A. You can do that. If you're like, these only mistakes I made were stupid mistakes, I want to retake it. Cool. You can even retake it literally tomorrow. And listen to this part, Cole. Because in class, tomorrow, during class, you can take the retake. Do you get you don't have to come in early in the morning to do it? Now, how can I do that? How can I let you like miss an hour because I'm recording the video for it? Cole, please listen. This applies to you. Because I'm recording the video for it, and that means if you have to take a retake in class tomorrow, which you don't have to, but you could, you're all going to be here, right? Then you can just, whatever I do for the lesson, you can just go watch it at home that night, all right? So do you get how that saves you a ton of time if you want to take retakes? You don't have to come in the morning to do it. You do it during my class. All right? Okay. So I'm hoping to make it easy to take a retake if you want one. But there are 2 things you have to do. Number 1, you have to make corrections on your test. If you don't know what you did wrong, you just didn't do it wrong again. Okay, so on your test, if you're going to do it on your test, you have to use a different color pen. Okay? So that I can tell the difference between what you did originally and your new fixed work, okay? Ideally, if I have enough of the copies, I can just give you another test and you can write on there and just fix the ones you got wrong. You don't have to fix all of them, only the ones you got wrong. So if you got 5 wrong, fix all of those, all right? So if I've got an extra copy of the test, I'll hand it to you, but I already know that if people took the yellow test, I'm out of those. So you can just write on your test, but you need to use a different color. If you use pencil, then use a pen. If you use black pen, then use red pen. You know what I mean? Use something different so I can see that you did corrections. Very important. If you write in the same color as you wrote the first time, it's not going to count. You'll have to do it over again. So corrections have to be in another color. And the last thing is, if you didn't do your homework, I'm not gonna put in your new retake score until you do your homework. Okay, so let's say that you retake it and you get this straight A and you're like, sweet, I get an A. Not until you go do your old homework. You don't have to do it perfectly, but you have to do it. And I was telling you to do it the whole time, so that like shouldn't be a surprise. That's the reason, is because now at retake time, if you didn't do it, it hurt you twice. It hurt you because you didn't do as good on the test as you would have. And number two, now you can't get the retake score put in until you turn in your missing work. So I might have a scenario where I got a kid who's done the retake, got an A, but I haven't put it in yet, because you haven't turned in your late work yet. All right? All right? Cool. Yes?
Are phones allowed?
One more time.
Are phones allowed?
Are phones allowed? Yes, during this time, phones are allowed. Work on your worksheet. It is a Schoology quiz thingy, and I'll start calling you up to give you your test back.